All right, kiddos, this is problem 2 of your longbowman worksheet. So now our longbowmen, they want to increase their range because, as we know, war is much easier when fought from a distance. So they're on top of a 15-meter tall hillside, and now they're launching their arrows still at 45 degrees, but now on top of the hill. So we found out from the last problem that our initial velocity of these arrows is 59.87 meters per second. We know that they are coming out at an angle of 45 degrees. And we want to know now what their range is going to be, or this distance. Okay? You guys have done this problem many times. You want distance. Well, distance is Vx times time. You want this, and you don't know the time, so there are two unknowns here. Okay, you can't solve this problem. To get time, you are going to use height. So my delta y is negative 15, because the arrows are coming down 15 meters. So the equation for delta y is V naught y t, and then plus 1/2 a t squared. Now, V naught y, how we find our initial y velocity is V naught sine of 45. So if we do that, we can plug that in. So delta y is negative 15 equals V naught is 59.87, and then sine of 45, and then all of that times time. Now, 1/2 a. Should be pretty used to writing this by now. A is negative 9.8. Half of that is negative 4.9. And then I've got a t squared. Now, before it would have been easy because usually our change of height is 0. But now, since I have this, I can't just divide both sides by t. This is actually a quadratic equation. If I add 15 to both sides, I get 0 equals 15 plus. Now, 59.87 times sine of 45 is going to be 42.33, and then that times time minus 4.9 t squared. Quadratic equation. So, t equals negative b plus or minus the square root b squared minus 4ac all over 2a. Now, the a is whatever is attached to the t squared. So a is negative 4.9. B is 42.33. And C I've got coming in as 15. So plug those into this equation, and you would get 2 times, because it's plus or it's minus. You want the positive time, or 8.98 seconds. Now, if you look back at problem 1, you would see that our hang time in that problem was less than that. It was only about, 8.64 seconds. So our arrow is in the air longer. That means it must be going further. So now that we know time, excuse me, rest of the problem, plug that back in. So I am looking for dx. Now, I don't know Vx, but I do know that Vx equals V naught cosine of 45. So plug that in. V naught is 59.87. And then I'm going to go cosine of 45 degrees. And then all of that times our time that we got is 8.98. Plug that into your calculator, and you would get a new range of 380. Catch up with me there. 380.16 meters. So, much further than when they were just on the ground. And if this was the scenario, you've also got a cliff top protecting you. Very nice. So that is part A. B asks you for the total hang time. You already used it. So 8.98 seconds. Now, C asks us with what speed does the arrow hit the ground? Okay? So, if you look at it, it's going to be coming in at an angle. It's going to be coming in hot, too. Let's call that V final. Now, we don't know V final, but we do know our V initial. So, to find V final, what we're going to have to do is we're going to have to find the components of that vector, because here's our V final right here. So there's V final. We need to know Vx. We also need to know Vy final. Now, Vx doesn't change, okay? So Vx, we've already found it. It's 59.87 cosine of 45. Okay? So if we do that, I get a Vx of 42.33. Okay? And why doesn't Vx change? Because there is no acceleration in the x direction. So our initial Vx is the same as our final Vx. Now to find Vy final, okay? How we're going to do that, we know how long the arrow is in the air. So t equals 8.98 seconds. And I know my initial velocity. Well, if I want to know V final and I know V initial, does this equation ring a bell? V at. Now, I want to know, I'm going to change it up a little bit, but it means the same thing. Vy final, well, V initial is my V initial y plus my acceleration times my time. Now, V naught y, we know as V naught sine of 45. So plug that in. Vy final is what I'm looking for. V naught sine of 45 is 59.87 sine of 45. Now plus my A is negative 9.8 and my T is 8.98 seconds. So this becomes a simple, just plug it into your calculator. So Vy final equals, if we plug that in, we get a Vy final of negative 45.66 meters per second. Now, the reason it is negative, it's a very small number. It's because it's moving down. It's moving back down towards the Earth. So it is negative. So now we know two sides of the triangle. Find the hypotenuse. Use the Pythagorean theorem. Vy final, or excuse me, V final, our final velocity, squared, that's our hypotenuse, equals Vx squared plus Vy squared. Vy final squared. So square root both sides, plug in your values, and you would get a V final of 62.27 meters per second. Okay? That is how fast that arrow is going to hit your body. The thing is moving. Okay? So, Pythagorean theorem. You know both sides, find the hypotenuse. And stay tuned, and I will show you in the next video tutorial how to solve the third problem on your Long-Bowman worksheet.